Hi guys, so today we're going to be talking about which method is best when solving systems, but just as a quick refresher, we want to talk about the three cases that we have when we have systems of equations, right? So first is when there is one solution. In those cases, the graph would look something similar to this, where the lines intersect exactly once, and as a result, the slopes are different. Okay. When we use substitution or elimination, we'll get things like x equals this, y equals this. Even x equals 0 or y equals 0 is okay. That just means it's at the axis, right? Our second case is if we have no solutions. In that case, the lines never intersect. Okay? And because of that, they never intersect. The lines are parallel, which means that the slopes are the same, but the y-intercepts are different. We know that this is the case when we're using substitution or elimination and we result in something that is never true, such as 3 equals 5. And then our third situation is when we have infinite or infinitely many solutions. That's when our graphs are right on top of each other. The lines intersect in every single point on that line. Okay, the slopes are the same, the y-intercepts are the same because they are the exact same line. And this usually results in, this is always true statements such as 3 equals 3, whereas we previously saw something like 0 equals 0. Okay? So those are our three cases. This is what they look like graphically, or when we're doing substitution or elimination. Okay, this is also what we know about their equations. So now let's talk about which method is best. So we've learned three methods of solving. We've learned how to solve by graphing, substitution, and elimination. Okay. So graphing, the best time to use graphing is when the equations are in slope-intercept form. Okay. When your equations are in slope-intercept form, both of them, we want to graph. Okay. However, what we need to understand is sometimes our solutions are fractions or something in between. In those cases, graphing only helps us to estimate solutions, right? So when we have something like our solution is 3.5 comma 1.5, graphing is hard. How do we know it's 3.5 versus 3.6 versus 3.54, something like that? So whenever we have a decimal or a fraction answer, graphing only gives us an estimate. We want to use substitution whenever one of the variables, either x or y, has a coefficient of 1 or negative 1. Okay? Sometimes this is possible by dividing one of the equations by a constant. Okay? And another way of saying that is also when our equation is something simple like x equals or y equals. Right? Because it's already solved for that, it's easy to just substitute it in as a result. Okay? We want to use elimination when one of the variables has the same or opposite coefficients, or when it is not convenient to use any of the other methods. Okay? For me, I actually really like elimination best, but everyone has a different preference, and these are times the best time to use it. Okay, so here, based on the equations, we're going to determine when it's best to use substitution, elimination, both. We're not really going to talk about graphing here because, as you can see, none of them are both in slope-intercept form. Right, so that's why we're not going to choose that. And again, graphing sometimes only gives us an estimate. Okay, and then we're going to justify, we're going to explain why we chose that, but we're not going to actually solve the system. Okay. So here, for question A, 2x plus 3y equals negative 11, negative 8x minus 5y equals negative 9. For me, I would choose elimination. Okay. The reason why is because for me, both are in standard form. I would not choose substitution because, as you can see, they all have a coefficient that isn't 1, right? 2, 3, negative 8, negative 5. right? And I don't have something easy like x equals or y equals. So substitution is probably not the way to go. Okay? So B here, I have 3x plus 4y equals 11. I have 2x plus y equals negative 1. Okay? So here I would use both, actually. Either one would work. Okay? So substitution, I would choose substitution. Right? Because y has a coefficient of 1. Right? So here for this one, right, substitution, because y has a coefficient of 1. Here, since it's 1y, it's easy to just move that 2x over by subtracting and then substituting it in. Right? I told you that I really like elimination. Elimination is also a good method here. Because they're both in standard form. It's easy to either make the x's 6 and negative 6, or in this case, since y here is already 1, it's easy. Since this is 4, I just multiplied this whole bottom one by negative 4. It easily cancels out the y's. Okay, so I'm going to have you try the next one on your own. So for C here, which method is best? Elimination, substitution, and y. So for C, elimination is the way to go. Again, they're both in standard form. And also because here our x have opposite coefficients. 3x and that negative 3x, when we add it together, it nicely cancels out. To solve for y, we plug it back in. Okay. So what about D? So y equals negative 2x plus 5, 3x plus 5y equals 7. Which method is best? Okay, for D here, I would have chosen substitution. The reason why is that first equation is already y equals, so nice and easy. All I have to do is take that and substitute it in for the second equation's y, and then I can nice and easily solve it. Okay, so what about E? So for E here, I would have chosen elimination. Both of them are in standard form, and because of the opposite coefficients for x, right? I have x and negative x. Both of them have a coefficient of 1 and negative 1 here. So they nice and easily cancel out. If you want, you could also do substitution. It's pretty easy to move, since the coefficient is 1, to just move that negative 7y over by adding it and then plugging it back in. But in my opinion, I think elimination is the easiest way to go. If you have any questions, please let me know. Have a great rest of the day. Bye, guys.